Okay? Difference quotient for any quadratic function is this. So all you have to do is identify A, B, and C in this one, and you can write out its difference quotient, right? So the difference quotient is, well, first of all, it's 2AT plus B plus A times H. And that equals what? Well, A is what's in front of T squared. It's 2 times 0.01 T plus B. Well, B is what's in front of T, so that would be negative 2 plus A times H, which is 0.01 H, which is 0.02 T minus 2 plus 0.01 H. Okay? Now if I give you T and H, you're going to be able to tell me the number that goes with the difference quotient, right? Let's stop before I do that and figure out what's going on here. Okay? Well, you should know how to graph this function. Axis of symmetry is negative 2 over 2 times 0.01. That would be T equals 100. So the graph of our function axis of symmetry is T equals 100. The vertex is on the axis of symmetry. 0.01 T squared is 100. That would be minus 200, which is negative 100. Plus 90 gives us negative 10. Okay, there's your vertex. Okay, the y-intercept is what? How do you get the y-intercept? Something you got to know instantly for the rest of your life, right?
Quadratic formula.
I'll give you the zeros, I'll give you the x-intercepts. So it's not a bad answer, but it didn't answer the question, so it wasn't a great answer. But it's, yeah, it gives you intercepts, but it's the x-intercepts, right? And you see they're going to be, you know, it's down here somewhere, because you're only about 10 units below the axis. How do you get the y-intercept?
Plug in 0 and then T.
The y-intercept occurs when x equals 0, because everywhere on the y-axis the x-coordinate is 0, right? Now if you didn't lock that in back in January, lock it in now. That's how you get a y-intercept. And you get an x-intercept when y is 0. Okay? You knew that perfectly well not long ago. Of course, January is a long time. It was winter back then. Okay? So you plug in T equals 0, you get what? You plug it into this, right? If T is 0, you get?
90. No.
Sorry?
Wait, we're plugging it into the equation or the difference?
Well, y equals f of t, right? And y is supposed to be, and t is supposed to be 0, right?
So 90.
You get 90, because this gives you 0 and this gives you 0, because t is 0. So you have (0, 90), and you have the vertex, and you know what a shape of a parabola looks like. So if you can draw a decent parabola, give myself half decent on that, okay? There you got your graph, okay? Now what I want to know is okay, I'm going to Let's do the fundamental triangle for the interval that goes from here to here. Well, what's the interval corresponding to this fundamental triangle? There's a fundamental triangle, right, between 2 points of the graph. So, according to reasonable estimates, what interval of the x-axis or the t-axis corresponds to that fundamental triangle? Well, it would be the interval from here to here, wouldn't it? That's what we mean by the fundamental triangle for an interval. We take the point at one end of the interval, which would be this, and the point at the other end of the interval, which would be this. And we construct the fundamental triangle. That's language you need to understand, but we've used it a number of times in the last couple of weeks, so I assume you do. Many of you solved problems correctly doing that. I think some of you even appeared on the midterm. Okay? So what do you think this interval is? I mean, what are the endpoints of the interval estimated? Give you a hint. Here's 100, here's 0. So what do you think this endpoint is?
33.3 repeating.
33.3, obviously 33.36. But you're sitting at an angle, so it's all right. Okay, well, I think it's more than a third of the way here. So I think you're kind of close. I'm going to say 40, just to use a round number. Okay? So we're going to use the interval 40. And what's this? It looks more like 80 than 70, but 70 is not, yeah, I think it's more like 80. So I'm going to use the interval 40, 80. Okay, what's the slope look like on that interval? I mean, by estimates, what would you get for the slope on the interval? Well, it helps to estimate the y-coordinate of each point, right? So this point is what? And this point is 80 what? Hard to draw a pointed arrow with dull chalk, okay. But you understand I'm talking about this point. Well, what's the y-coordinate look like here? You got a scale, right? I mean, 90 here gives you a scale. If this is 90, what's this? I know everybody's thinking it's 20. There's 10. So I'm going to say that point's 40, 20. And, you know, I pointed at the axis here, so I really screwed up that arrow. But we're talking about this point, right? And what's the x-coordinate look like? Well, the vertex is 100, negative 10, so that would be like negative 10, and this isn't much higher, right? So if this is negative 10, I'm going to say that's negative 8. can't prove me wrong, you might have a different opinion. But don't tell me it's negative 17, because it can't be lower than the vertex, right? Okay? So, now, what are the rise and what are the run? If I go in this direction, my rise is from 20 to negative 8, so the rise is negative 28. The run is from 40 to 80, which is 40. Didn't leave myself quite enough room, but there it is, okay? And you can label it yourself, you know how to do this. So what's the slope? It's negative 28 over 40, right? So the slope is negative 0.7. I'm not going to write out the details of that. If you have these points, you know that the slope, you know how to find the rise, the run, and you can find the slope. So it has slope approximately negative 0.7. Okay. Now, I'll be shocked if this comes out really close. But I think it might come out within a tenth. Okay? And it's just dumb luck if it comes out any closer than that. And if it doesn't come that close, I'm still not surprised. Okay. So make sure that looks like a plus sign, not a T. Well, if t equals 40 and h equals 40, then the interval from t to t plus h is the interval from 40 to 80, right? I'll say that more slowly, but go ahead and figure out what the difference quotient would be if t and h are both 40.